Guys, in this video, I will try to cover the Feynman's trick through some examples. So, first of all, what is Feynman's trick? Feynman's trick is a kind of application of differentiation under integration where you can solve any kind of integral using the Feynman's trick. And in some of the cases, maybe you will face some integrals which it's like you can't solve it, or maybe it is unsolvable or something like that. Like if I'm talking about sine x by x, integration of sine x by x 0 to infinity x, it is a kind of unsolvable integral, but using the Feynman's trick we can easily solve it. But before coming to that question, I will talk about another question so that you can understand. First of all, uh, the examiner will provide you the integration looking like that. Let's say I'm taking an example. Ignore this question now, focus on this question. So log of 1 plus cos a cos x whole divided by cos x. Now basically you can see there is a kind of a and there is dx, so a will be treated as constant inside the integration, but we are talking about I of a, which is basically nothing but this is kind of function of I. Then answer will be in the form of a or something like constant. So what do you have to do? Like you have to find out the I dash a, and after that, using the integration rule, basically it's a kind of a fundamental rule of integration. Using that, you can easily find out IA at the end of the day, and you will get an indefinite integral. So you have to take a c, which is kind of indefinite integral constant, and you have to find out c by equating IA is equals to 0, and you have to equate this portion equals to 0. You have to solve this will be equals to 0, and you have to find out the value of a, so that the value of IA will be 0. From this you will find out the value of c, then you finally can find out the value of IA, which is, let's say, a function of a plus c. You have the c and you have the fa also. And how you can find out fa? Using this. So I know it is a little bit confusing, but let's talk about this example so that you can understand easily. So first you have to find out I dash a, right? So I have to find out I dash a, and as we are talking about two variables, so we have to take the partial derivative, basically the del a. So this is 0 to pi by 2 log of 1 plus cos a into cos x divided by cos x dx. Now basically 0 to pi by 2, we have to do this, we have to differentiate this, right? Because the term of a in like is multiplication of cos x, right? So basically we have to do the simple integration. This is cos x into, we have to do the differentiation of this numerator. So this is 1 plus cos a into cos x. At the upper portion, this is, we have to do the differentiation of the inner function, which is 1. This will be like 0. This is cos a, so this is minus sin a into cos x into dx. Because if we are talking about the differentiation with respect to a, then x or any kind of function which is fx or gx or whatever it is, it will be treated as constant, right? So this is the differentiation. Now you can see easily that the cos x and cos x will be cancelled out, and sin a will be treated as constant because we are doing the integration now, right? So minus sin a into dx 0 to pi by 2 1 plus a into cos x. Now what is capital A? Capital A is nothing but cos a. In that case, capital A is also a constant. Now solving this integrals is a little bit this is a little bit complex integral. So I'm not talking about complex integrals, okay? I'm talking about the complexity. However, so basically how we can solve it. So you can see we are talking about this integral, not the sin a. So let's say this is I. So I is equals to 0 to pi by 2 dx by 1, but we are writing 1 as sine square a by, sine square of x by 2 plus cos square of x by 2. As you know, the sine square a plus cos square a is equals to 1. So we can replace 1 as something like that, plus a. We are using the formula of cos x equals to cos square x by 2 minus a into sine square x by 2, right? We are using the basic formula. Hope you don't know, hope you know. So however, so now this is 0 to pi by 2, and like this is 0 to pi by 2, and dx, this is cos square x by 2 into a plus 1, right? Cos square x by 2 into a plus 1 plus sin square x by 2 into 1 minus a, actually. Very nice. 1 minus a. Okay, fine. Now, how can we proceed? So basically, you have to take the, we have to multiply sec square x by 2 at the numerator and at the denominator also. 0 to pi by 2. This is sec square x by 2. This is dx. This is 1 because sec square x by 2 into cos x, cos square x by 2 is 1, nothing but. So basically, this is a plus 1 plus, now sine square, like sin x into cos x, sorry, sin x into sec x, right? Sin x into sec x is nothing but sin x by cos x, which is tan x. Now we are talking about the squares, so this is tan square x, right? Specifically, this is tan square x by 2 and 1 minus a into tan square x by 2. Now let's move on to the next page. Now you can see this integration, and it is very easy to solve. How we can solve it? Just to have to take a simple approximation, a simple transformation, or if you know the D method, then you don't need to take a transformation even. However, I'm not talking about D method or direct method actually. So let's proceed through the transformations. So I have to take a simple transformation, which is root over 1 minus a by 1 plus a into tan x by 2 is equals to z. So basically, tan x by 2 is equals to z into root over 1 plus a by 1 minus a, right? So now basically you have to using the differentiation at the both side using we have to find out the differential equation so that you can replace. So basically the differentiation of tan x is sec square x by 2. Now the differentiation of x by 2 is half is equals to, with a dx, sorry, dz into 1 plus a by 1 minus a. It's very easy to solve. Someone is shouting, I don't know why, maybe he or she is a mad person or something like that. Just ignore. Well, ignore like or eggs. So basically we have to replace. So you have to take a 2 here, there is a half 2, this is not z, okay, this is 2, this is 2, okay, fine. So this is root over 1 plus z, 1 plus a minus 1 divided by 1 minus a into dz divided by, if we are taking common 1 plus a, then we will get something like 1 plus a into 1 plus z square. Now it is looking like very simple integral, right? So you have to solve it using the basic method. You can see this and this will be cancelled out and something like that will be happen, like so you have to take out 1 sorry for a mistake. So basically this is 1 minus a into 1 plus a integration of dz, this is 2 divided by 1 plus z square with limits of 0 to pi by 2. Now this is very easy, right? This is nothing but tan inverse z with limit 0 to pi by 2. So I am doing a simple step jump, you can understand, I guess. 1 minus a square. Now this is 0, this is what? Oh, sorry for a mistake. I had a big mistake, which is I I haven't changed the limits. Sorry, sorry. You can see if we are putting like pi by 2 at here, then the upper limit will be converted into, like, this is pi by 2, so pi by 4, right? Tan pi by 4 is 1, so the upper limit is root over 1 minus a into 1 plus a. And the lower limit, if we are putting 0, then tan inverse 0, I mean sorry, tan 0 is nothing but 0, so that is equals to 0. So this is not like that. This is 2 by root over 1 minus a square. I am doing a simple algebra, and this is tan inverse root over 1 minus a by 1 plus a, right? Minus 0, I am not taking the 0 because tan inverse 0 is 0, right? So now basically a is nothing but what? A is nothing but we have taken a equals to cos a, right? So I have to replace it. Now 1 minus a square, like 1 minus cos square a is nothing but sin a. So 2 by sin a. So 2 by sin a. And this is tan inverse. Because a square means 1 minus cos square. So you can understand, right? This is root over 1 minus cos a by 1 plus cos a. Now there is a simple formula which is called tan x is equals to 1 minus cos 2a by 1 plus cos 2a. If you don't know, then go to Google, you can understand. Sorry, there is a root. Now basically we can replace this from this. Now there is 2a and there is a, so there will be sin a into tan inverse tan, this is a, sorry, tan inverse a by 2, because we are talking about not 2a, we are talking about a. So this a will be replaced as a by 2, right? Now it's very easy, like tan inverse of tan x is equals to a by 2, right? So 2 by sin a into a by 2, 2 will be cancelled out, and a by sin a. It is very easy. Now we have to find out I dash a, which is equals to minus sin a into I, and value of I is this, so you can replace. Now sin a and sin a will be cancelled out, and the value of I dash a is equals to minus a. Now we have to find out the value of IA, right? So we have to integrate it. So integrate this IA, and there is no limit. Be careful about that. So we will get a constant which is called indefinite integral constant, and we have to find out the value by equating I equals to 0, and we have to solve the first integration which we have provided to you. So basically the integration of minus a dA, the value of I dash a is equals to minus a. So integration of this is equals to minus a square by 2 plus c, right? It's very easy. Now let's move on to the next page so that you can solve this equation. Now it is given that IA is equals to log of 1 plus cos a cos x by cos x, hopefully it is visible, from 0 to pi by 2 dx, and we have to equate it with 0. So the integration will not be like existing, so we can say like log of 1 plus cos a into cos x is equals to 0, because we are also multiplying cos x at the both sides, because 1 by cos x, I mean cos x will not be 0, whatever it is, doesn't matter. Actually you can understand, right? So basically you can see this is 1 plus cos a into cos x is equals to e to the power 0, which is 1. Now 1 will be cancelled out. You can say like cos a is equals to the 0 by cos x, right? We have to find out the value of a. Be careful, we don't have to find out the value of x. So cos a is 0, so a is nothing but, actually a is nothing but 2n plus 1 into pi by 2, but we are talking about only pi by 2, because we are not talking about the second quadrant or third quadrant or fourth quadrant, because the limits are from 0 to pi by 2, so you have to talk about only for the first quadrant. So we have to take the value of, the first value which we will get. Like in that case, a is equal to pi by 2. So we can say that I a is equals to 0 when a equals to pi by 2. So we can say I of pi by 2 is 0, right? Right. Now according to the previous integration which we have solved, that ia is equals to integration of I dash of a dA, and the answer is like a square by 2 plus c, right? So we can say that I of this, like pi, we have to replace a as pi by 2, so pi by 2 whole square divided by 2 with a minus plus c, hopefully it is visible, is equals to 0. From this you can easily find out the value of c, which is equals to nothing but pi square by 4. So now we can replace the c with pi square by 4 so that we can find out the value of I a. So I a is nothing but minus a square by 2 plus c. We just have to replace the value of c. So this is a minus a square by 2 plus pi square by 4. This is the value of this integration. And maybe it is a little bit complex integration, but if you know the process, if the process is perfect, then you will get the answer for sure. uh, um, if you have done any kind of calculation mistake, then it's another scenario, but otherwise you will get the answer definitely if you know the process, if you follow the process. So let's move on to another example so that you can understand more powerfully. So in this question you need to find out the value of ia, and the function is looking like that. How we can find out? So we have to integrate, we have to differentiate with respect to a. Basically the differentiation is partial differentiation. I am not repeating the process actually. I'm just telling you the, I am just solving the question so that you can understand without any nonsense. Now, this is 0 to infinity, and integrate, differentiation of tan inverse x is nothing but 1 by a square into x square into x into 1 plus x square, and differentiation of x is nothing but x, because x is treated as constant. So xx will be cancelled out, so I have to integrate this, and after that integration you have to again integrate. So however, this is 1 plus a square x square, this is 1 plus that. It's very easy to understand. Now integrating this, it little bit complex. You have to know the formula, not formula actually, it is kind of sense or concept of partial fraction. So how we can define it? Like partial fraction, in that case a square x square into 1 plus x square into a square equals to a by 1 plus a square into x square plus b by 1 plus x square. Now you can easily equate both of them, and you will get something like a into 1 plus x square plus b into 1 plus a square x square is equals to 1. Now we have to find out the value of a, and we have to find out the value of b also. For that we can easily say that x square equals to minus, I know you can't understand this portion like x square equals to minus 1, so x equals to plus minus I or something like that. No, just you need to make it 0. Maybe the value of a is 0, maybe this is 0, doesn't matter actually. So however, make it 0 so that you can find out the value of b. So when x square equals to minus 1, then the value of b, like it will be like 0, and it will be b is equals to, the value of x square is minus 1, so b is equals to 1 minus 1 by 1 minus a square, right? And again, if we are putting 1 plus a square, sorry, this is equals to minus 1, then it will be like 0, it will be becoming 0, and the value of a is nothing but, if x is a square into x square is minus 1, so value of x square is minus 1 by a square. So we just have to replace it, 1 minus 1 by a square into not into, it is 1. So value of a is nothing but a square by a square minus 1. Simple step jump, hopefully you can understand. Now we have to replace it here. So the integration is 0 to infinity, and we have to integrate like a square by 1 minus, sorry, a square minus 1 into 1 plus a square into x square dx minus, actually not minus, actually plus, 0 to infinity dx by 1 minus a square into 1 plus, hopefully it is visible, 1 plus x square. Now this integration is easy and this integration is also easy, right? Because this is nothing but we have to take a 1 by a, this is like a into x, and this is tan inverse ax minus, I am taking common a minus so they can make, this is, we can make it a square minus 1. Now the integration of dx by 1 plus a square is again tan inverse x with the limits from 0 to infinity, right? Now basic algebra, hopefully you can understand. Now basically I am taking common the a square minus 1. The value of tan inverse infinity is pi by 2 for both this and this also. So like this is pi by 2 and this is also pi by 2. Just have to multiply a into pi by 2 minus pi by 2 because there is no a. So this is like a by a square minus 1, sorry, a minus 1 by a square minus 1 into pi by 2, and it is very simple to understand. This is nothing but pi by 2 into a plus b. Now let's move on to the next page. So the value of I dash a is equals to pi by 2 into a plus 1, right? Now we have to integrate it so that you can find out the value of ia. This is actually indefinite integral, so you will get a constant which is called indefinite integral constant. Now pi by 2 is constant, we have to integrate dA by 1 plus a or a plus 1, however. So this is nothing but pi by 2 and this is ln 1 plus a with a mod, but doesn't matter actually. You can put the mod, actually doesn't matter. So however, plus c. Now we have to find out the value of c. How we can find out? We have to just equate ia is equals to 0. From the beginning we can say that ia is nothing but 0 to infinity tan inverse ax by 1 plus x square into x dx. We have to equate it. What I'm saying, we have to say that I equals to 0 and we have to find out the value of a. So how we can find out? We can just have to ignore the integration and we have to find out the value of only tan inverse ax is equals to 0. Find out the value of a because this will be multiplied at the left side, or you can say right side, and it will be like 0. So the value of ax is equals to 0. So we have to find out the value of a, not the value of x, right? So the value of a is 0. Okay, fine. So we can say that when ia is equals to 0, when a is equals to 0, so we can say that I0 is equals to 0. I0 is equals to 0. This is not a, this is 0 actually. So we can say I0 is equals to 0. Now I0 means we have to replace here the a with 0. So pi by 2 ln 1 plus 0 plus c is equals to 0, right? Now this is nothing but ln 1 and the value of ln 1 is 0, right? From the graph we can easily say that the value of ln 1, this is ln 1 and this is nothing but 1 comma 0, right? So at the value of this is ln x. So the graph is looking like something like that. Actually the graph is not like that, graph is looking like that actually. However, just assume it. So the value of ln 1 is 0. So this is pi by 2 into 0 plus c is equals to 0. So the value of c is 0 So we can replace C as 0 at that equation so that we can find out the value of IA. So IA is equals to pi by 2 ln 1 plus A plus 0. So the value of IA is equals to pi by 2, this is pi, ln 1 plus A, and this is the final answer of that question. So this is all about this video, and the next video maybe I will solve the integration sine x by x 0 to infinity, which is a little bit hard question, because in that case, when you will deal with a function where there is no kind of any kind of, like, you will not see there is a, right? In that two questions which I have solved at that video, you may see like there's a kind of a, so that we can differentiate it. But in the case of sine x by x, you have to take another function which is equals to 1, but you have to replace it, and maximum cases we have to take that, so that we can say when we are putting the upper limit, then it will be 0, and when we are putting the lower limit of x, then it will be 1. This is the actual process, but in the next video I will talk about that. And although you don't need to know about this integration for the semester exams, you just need to know the process which I have told to you through this video. And that's all about this video. Thank you for watching, and just focus on the process so that you can do the numerical or any kind of question which you have faced, which you will be going to face. And nothing more than that. Thank you for watching this video. If you want to subscribe, if you want to comment, like and share, then do it. And goodbye. Thank you.